So student, now we'll start. In the previous lecture we will do that how we can change the solid into liquid, liquid into gas, and reverse this reaction from the gas to liquid and liquid to solid by the different process. And now we read in this lecture how which are the processes or what are the processes through we can change the state of particular matter. First is melting. The change of solid substance into liquid state is known as melting. Solid ice melt into liquid water when it's kept in a warm place. The particle of the ice take up heat from the surrounding and start vibrate faster. This break the rigid pattern of the particle arrangement and they start moving freely around each other. Thus solid ice melt to form a liquid. Means its best example is melting. Means here we change the solid into liquid. For example, when we have an ice cube and we take the ice cube from the freezer and we kept these ice cubes outside from the freezer, and they will take the heat from the surrounding and easily change into the liquid, because when they take the heat from the surrounding their particles are vibrating fastly. So here when they vibrate, the force of traction between the particles of the ice cube will break down and change into the liquid easily. So through melting we can change the ice cube into the water, means we change the solid into the liquid, because ice cubes are the solid and we change it into the water is liquid. After freezing, the change of a liquid substance into its solid substance is called the freezing, and water freeze into solid ice when it kept in the freezer, and the particles of the water lose heat and their movement. Eventually the particle come closer and become tightly packed, thus it take the form of rigid ice. Means here now we have to change the liquid substance into the solid substance. Now we go back, and for example, when we have the water and we kept the water inside the freezer, and here the water lose the heat because now it's going in the cool place and their movement. Okay, so eventually the particle of the water become closer to each other in the freezer and they become tightly packed, and the force of attraction become very strong among the particles. So here we get the form of rigid ice, means now liquid change into the solid. Through the melting we change the solid into liquid, and through the freezing we change the liquid into the ice. Best example is water, which I will give you. Okay, vaporization. Vaporization is the change of the liquid substance into its gaseous form. Liquid form turned into vapor when heated in a container. The movement of the particle of liquid become extremely fast on heating and they move far apart from each other and turning into gases. Vaporization means now we have to change the liquid into the gaseous state. Okay, for example, you will see in this image we have now water in this pan and we will heat the water. Okay, when we heat the water, so the boiling point of the water is 100 degrees Celsius, and when we heat the water above the 100 degrees Celsius, this will change into the vapors. You will see here we get the vapors in the form of steam. Okay, so we get the water or vapors in the form of steam when we boil the or heat the water above the 100 degrees Celsius. Okay, because boiling point of the water means 100 degrees Celsius. Boiling point is that point where the water goes for boil. We get the water is boiling, but above the 100 degrees Celsius we change the water into its vapor form or steam form. This here we change the liquid into the gaseous state. You will see we read the three. Melting, we use the solid to liquid. Freezing, liquid to gases. Vaporization, liquid to here you will write liquid to solid, not gases. Here we get the liquid to gases. Okay, these three process: melting, freezing, vaporization. Through melting we change the solid into liquid, freezing liquid into solid, and vaporization liquid into gases. Okay, now condensation. Condensation is the change of the gas into liquid form, and we see the water droplet on the outer surface of glass with cold water or ice in it, and water vapor in the air near the glass cools down, and when it comes contact with the cold glass, and the cool molecule become slow and come closer to each other. As a result, a teeny water droplet appear on the glass surface. It's best example I will give you. For example, you will heat the water. Okay, it's an example of condensation. And when we heat the water, and at 100 degrees Celsius the water going for the boil, but when we heat above the 100 degrees Celsius, now it's changed into vapors. Means here what is doing, we're doing the vaporization. Okay, but we have to read the condensation. It is the reverse method of the vaporization. Here, when we boil the water above the 100 degrees Celsius, it's go for the vapor, means vaporization take place. But now when we put the plate on that particular container, okay, or we can say we not give any space to the vapors. We put the plate on the containers. Now these vapor which are going outside in the atmosphere, they come back in the form of liquid drops again in the particular container from its starting for the vaporization. So this process is called condensation. I will repeat that when we have now water in this container, and when we boil the water at 100 degrees Celsius, now it's boil, but above 100 degrees Celsius it's changed into vapors. Okay, this process is called vaporization. But when we put a plate on particular container, these vapors will not go outside, and this will come back, or we can say this will return to this particular container in the form of liquid drops. So this process is called condensation. Okay, now we'll read the expansion and contraction. Okay, when we heat a substance, its particle gain energy and start moving away from each other. This is called expansion. Example, when it is difficult to open a bottle of jam with the metal lid, the lid is heated gently, and the metal lid then expand and loosens its grip on the bottle and can be opened easily. Okay, for example, they're saying that then when we heat a particle substance, they gain the energy, and the particles when gain the energy, they fastly move from their particular position. This is called the expansion. Okay, expansion means you also see that in a summer, if we see the railway tracks, due to the summer season, the railway tracks come closer to each other. The gap inside between the tracks of the railway having less, because they get expand and they want, or they goes for toward each other. But in the summers they can get contract, and they have the gap increase. They have the proper gap in the winter season. Sorry, in the summer they have less gap because they goes towards each other due to the expansion. But in the winter they contract, and there is a gap increases between them. Now they give the example of the bottle of jam. When there is a difficult to open the particular bottle of the jam, and when we heat the bottle of the jam, the particles starts move of that particular material which is present inside the bottle. So okay, and then we can open the lid of the particular bottle, because now the expansion take place inside the bottle, because the metal lid then expand and loosen its grip on the bottle. Means now the lid which is present on the above side of the bottle, its grip can be loosened through the bottle when we heat the bottle, and this is called as expansion. Gases show maximum expansion, where solids show minimum expansion. Here the gases show maximum expansion because the space inside the particles in the gases are very much large. That's why they easily expand by heating, where solid show minimum expansion because in the solids particles are very close to each other. That's they will take more time to expand from their particular position. Okay, after that, when we cool a substance, its particles or particle come closer and occupy less space, the substance contract or shrink, and this phenomena is called contraction. Okay, for example, its best example we will also we done in our previous lecture, that when we cool a particle substance, they will go for the contraction. For example, when we put the water inside the freezer, and the particles of water will lose their heat inside the freezer, and they come close to each other and they contract and form a ice cubes. This process is called contraction. For example, if we keep a empty mineral water bottle in a freezer for an hour, we will find that it shrink and get deformed. This happens due to contraction of air inside the bottle, and when the air get cooled, the air particle come closer and occupy less space. As a result, the bottle gets squeezed. Means they also give another example, like when we put a bottle inside the freezer, the water molecule also get come close to each other because they lose the heat inside the bottle also, and the air which is present inside the bottle, the particle also will come close to each other due to the cool downs. So they occupy the less space, and that's why the bottle will also shrink and the bottle change its structure due to the contraction. Okay, so here we also reading about the reversible and irreversible changes. Reversible, the properties of material can be changed. Some changes are irreversible while some are reversible. They said that some changes are irreversible, means we can go back into the initial position, but reversible we can't go. Means irreversible we cannot back into initial position, but in reversible we can go back into its initial position. Okay, so a change is called irreversible if it cannot be changed back into again. Irreversible means we can't go back into the initial position. For example, we cannot change a cake back into its ingredient again, so we can say irreversible changes are permanent. For example, when we have a cake and we make a cake through the different ingredients, now we cannot go back into the ingredient through the cake because we have a cake which is made permanent, so it is called irreversible change. Okay,